So question number 22 is you have to find out the derivative of x raised to 4 into 5 sin x minus 3 cos x. So we are taking this question as f of x, so that f dash of x, you can use this product rule for this question, right? So x raised to 4 into derivative of this d by dx of 5 sin x minus 3 cos x. Derivative of 5 is a constant, you can take out, and sin x, derivative of sin x will give you cos x, minus 3 derivative of cos x will give you sin x. So this will become minus sin x will become here positive sign, okay, plus derivative of x raised to 4 into this term. Derivative of x raised to 4 will give you 4x cube into 5 sin x minus 3 cos x, okay. Now you have to just expand it. This will give you 5x raised to 4 cos x plus 3x raised to 4 sin x plus 20x cube sin x minus 12x cube cos x. So nothing can be, if you want you can just combine the sin x terms and then cos x terms, like that you can take out, else it is like this. Taking out x cube in common, what you will get, this is 5x cos x. Here you have 3x sin x plus 20 sin x minus 12 cos x. Like this you can make it, okay. So this is the derivative of the given function. Dash of x for the given question x square plus 1 into cos x will be x square plus 1 into derivative of cos x. We are using product rule, so you will get minus sin x plus cos x into derivative of x square plus 1 will give you 2x plus 0. So it is 2x. So you are getting minus, this is minus sin x into this term. So first we will write positive term, that is 2x cos x, this one, minus x square sin x minus sin x, okay, equal to ax square plus sin x into p plus q cos x. F dash of x will give you ax square plus sin x into derivative of p plus q cos x plus p plus q cos x into derivative of ax square plus sin x. So that will give you ax square plus sin x into derivative of p 0, q can be taken out while taking the derivative of this term, q into derivative of cos x will give you minus sin x. So this will become minus q sin x, 0 minus q sin x, plus p plus q cos x into derivative of this will give you, again a is a constant, derivative of x square is 2x. So this term becomes 2ax. And derivative of sin x is cos x, so it is plus cos x, okay. Multiplying, what you will get, a q x square sin x plus, minus q sin square x plus into p into this term will give you 2ap x plus p cos x plus q cos x into this term will give you 2qa x cos x plus q cos square x. Now here you have q sin square x minus q sin square x, and there you have q cos square x. So this can be, that is q can be taken out, but it is not actually 1 because here negative and there positive. So it will become only, either you can use the property that you know that cos square x minus sin square x is giving you cos 2x. So that you can make. Okay, so one term will be removed here. So if I am taking q out, I will get cos square x minus sin square x for these two terms, this one and this one. Remaining is same, that is minus aq x square sin x plus 2apx plus p cos x plus 2aq x cos x. This term will be written as cos 2x minus aq x square sin x plus 2apx plus p cos x plus 2aqx cos x. Okay. Not compulsory that you need to do these steps, you can stop till this also. Okay. x into x minus tan x. F dash of x will give you x plus cos x into derivative of x minus tan x plus x minus tan x into derivative of x plus cos x, which is equal to x plus cos x into derivative of x 1, derivative of tan x 6 square x plus x minus tan x into derivative of x1, derivative of cos x minus sin x. So it is 1 minus sin x. Okay, so I am telling that you can stop here also, need not expand it further. Okay, because the expansion will not give you anything, means you can stop here. 4x plus 5 sin x whole divided by 3x plus 7 cos x. So the derivative you can use as quotient rule is, what is the denominator? 3x plus 7 cos x into derivative of 4x plus 5 sin x minus what you will get, 4x plus 5 sin x into the derivative of 3x plus 7 cos x whole divided by 3x plus 7 cos x the whole square. This is your quotient rule, right? 3x plus 7 cos x into, what is the derivative of this? Derivative of 4x will give you 4 plus derivative of 5 sin x, 5 is a constant, derivative of sin x is cos x minus 4x plus 5 sin x into derivative of this term. Again, derivative of 3x will give you 3 into derivative of x as 1. So this is 3 plus here 7 cos x. So 7 into derivative of cos x is minus sin x. So it is minus 7 sin x whole divided by 3x plus 7 cos x the whole square. Now multiplying, what you will get? This will give you 12x plus 15x cos x plus 28 cos x plus 35 cos square x. Because you have an option to get cos square and sin square, that's why we are doing. If it is of use or not, we don't know. Okay, so we are just have minus of 12x. Okay, so that 12 can go. Now here minus 28x sin x plus 15 sin x minus 35 sin square x whole divided by 3x plus 7 cos x the whole square. So here when you expand it, that is removing this bracket, you will get 12x plus 15x cos x plus 28 cos x plus 35 cos square x minus 12x plus 28x sin x minus 15 sin x plus 35 sin square x whole divided by 3x plus 7 cos x the whole square. So here you can see 12x and minus 12x get cancelled. Then anything else? 28 cos x. Okay, no. Now you have this option, that is taking 35 out and sin square plus cos square will give you 1. So 15x cos x plus 28 cos x plus 28x sin x minus 15 sin x plus 35 into cos square x plus sin square x, which will become 1. So you will have only 35 here divided by 3x plus 7 cos x the whole square. Okay. Of x equal to x square into cos of pi by 4 divided by sin x will give you f dash of x as cos of pi by 4, which is a constant, into d by dx of x square by sin x. That is enough. Okay. Now what is cos of pi by 4? Cos of pi by 4 will give you 1 by root 2 into d by dx, or else you just keep it like that, then also it is okay. Okay. Now d by dx of this we can use quotient rule here. So what is this? denominator into the derivative of numerator, which is x square, and the derivative of x square is 2x, minus, again x square is the numerator, derivative of sin x will give you cos x, divided by sin square x. So you have 2x sin x minus x square cos x divided by root 2 sin square x. Okay. Yes, x by 1 plus tan x. F dash of x, again you have to use quotient rule, which is 1 plus tan x, that is the denominator, into the derivative of numerator, numerator's derivative, that is derivative of x, which will give you 1, minus numerator into the derivative of 1 plus tan x. Derivative of 1 plus tan x will give you what? Derivative of 1 is 0 and derivative of tan x is sec square x. So this will be the term, divided by 1 plus tan x the whole square. Okay, so it is 1 plus tan x, nothing to do extra, you can stop there also. 1 plus tan x the whole square. This is the derivative of the given function. Next question is x plus sec x into x minus tan x. So f dash of x, again you can use product rule here. Okay, so d by dx of x plus sec x into x minus tan x plus x plus sec x into d by dx of the second term, which is x minus tan x. So here the derivative of x plus sec x will give you derivative of x1 plus derivative of sec x tan x into x minus tan x plus x plus sec x into derivative of x minus tan x. Derivative of x is 1, derivative of tan x is sec square x. So it is 1 minus sec square x. Now you just multiply, what you will get, x 1 into this minus tan x plus x sec x tan x minus sec x tan square x plus x, then minus x sec square x plus x to 1, x into sec x, and sec x minus sec cube x. So you can just combine this x and this x, that will give you 2x, become 2x minus tan x plus x sec x tan x minus sec x tan square x minus x sec square x plus sec x minus sec cube x. So it doesn't have any use here, only this part has been changed. Okay, so till this it is very important, remaining is not so compulsory. X by sine raised to n x, the power of sine is having n. Okay, again we will use quotient rule only. Denominator into derivative of numerator, which is 1, minus numerator, which is x, into the derivative of denominator, sine raised to n into sine raised to nx, divided by, again this will become sine raised to nx the whole square. So the power can be written as sine raised to 2nx. So here this will become sine raised to nx minus x into, now what is the derivative of sine raised to nx? Derivative of x raised to n will be n x raised to n minus 1, right? So derivative of sine x the whole raised to n, like this you have to think, sine x the whole raised to n will give you n into, instead of x you have sine x, so n into sine x the whole raised to n minus 1. But again, since it is not x, we will take the derivative of the term which is instead of x here, and that is sine x. So like this. So this is known as the chain rule. So here you will get n sine raised to n minus 1 into x. Into x means this is the power, okay, sine x the whole raised to n minus 1 into the derivative of sine x, which is cos x. This will be the derivative of sine raised to nx. So we are just replacing that value, n x sine raised to n minus 1 x cos x divided by sine raised to 2n x. Okay, Now if you want, you can take out sine raised to n minus 1 in common from these two terms, and that is again not compulsory, but this will give you sine raised to n minus 1. Here you have an option to get that reduced form of the power of sine. That's why we are taking it out. Here you have sine raised to n minus 1, here it is sine raised to n. So we are taking it common as sine raised to n minus 1. So the remaining here will be only one power of this. So it is sine x. Okay. Minus nx, this has been taken out, nx cos x, divided by this is sine raised to 2nx. Now these two can be combined. Actually the base are same, sin x, the powers are n minus 1 and here it is 2n. So what will happen to the power? If I take this to the denominator, this will become 1 minus n. If I take this sine term in the denominator, this will change its order, its power will change, or else you can just see that this is sine raised to n minus 1 x, and this will go up and its power will become sine raised to minus 2n x, like this, so that the powers can be added and the power will become raised to n minus 1 minus 2n x. So these two, what will give you? Sine raised to minus 1 is there, minus 2n plus n will give you minus n, right? Or else I can write it as sine raised to, x is also there, sine raised to 1 plus n x, right? So I am just combining these two. So this is in the numerator. If I am taking the denominator to the upper part, it will give you like this. That means in the denominator this negative will go and I will get the power of sine as n plus 1 or 1 plus n. Okay, so I am just writing that in the last part, which is sine x minus nx cos x, and simplifying these two like this, what you are getting the power of sine as is n plus 1 x. So while talking for this limits involving exponential and logarithmic functions, first we will discuss what is exponential function and what is logarithmic function. Okay, exponential function. You have heard about e. It is a value which lies between 2 and 3, 2.7183, like that its value is 2.7183. E is actually 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus etc. Like this you will give. So this is 1, this is again 1 by 1 factorial is 1 again, so this will become 2. 2 plus 1 by 2 factorial means it is 1 by 2. 1 by 2 is 0.5. So as you go